In this example, we are going to use Jefferson's method of apportionment, and it's named after President Thomas Jefferson. And his method is similar to the first three steps of Hamilton's method, but then it deviates from there. So this problem says, suppose the greater metropolitan area of a city needs to apportion 35 seats in its council. There are 5 wards within the metro limits: the 1st, 2nd, 3rd, 4th, and 5th ward. Use the population of each ward shown in the table to apportion the 35 seats. So here we have this table here. We have a total population of 569,150, and we have these subgroups here: 1st, 2nd, 3rd, 4th, and 5th ward, and we want to be able to apportion 35 seats. So the first step of Jefferson's method is the same as Hamilton's first 3 steps. So I'm just going to put down here step 1. In Hamilton's, he states to find the standard divisor. So I'm just going to put down SD, find the standard divisor. Then the second step of Hamilton's method is find the standard quotas. And I'm just going to put that as SQ. And then the third step for Hamilton's method is he then says round down, using the quota rule, then round down. So the first step of Jefferson's method is the first 3 steps of Hamilton's method. So we'll go ahead and we'll just do this first step here of Jefferson's method. We're going to find our standard divisor. So that is where we have the total population divided by the number of seats. So the total population is right here, 569,150. And we're going to divide that by the 35 seats right up here. So we'll divide that by 35. 569,150 divided by 35 is approximately 16,261.429. And 3 decimals is pretty much plenty for a problem like this. So now that we have our standard divisor, the next step of Hamilton's method is find the standard quota. So then we take this and we divide this into each one of the subgroups here. So we take the 16,261.429 and we divide it into here to 163,200. And I'm just going to write an SD here so that we know that that's the standard quota rather than have to write in 16,261.429 every time. We just know that that's what we're going to be dividing it by. And this comes out to be 10.036. We then divide this by the standard divisor, and the standard quota for here is 5.003. We divide the next subgroup by the standard divisor of 16,261.429. And the standard quota is 6.735. The next subgroup, this comes out to be 7.248. And divide the next subgroup by the standard divisor. And this is 5.977. So now we have all our standard quotas, which is the second step of Hamilton's method, but it's built into the first step of Jefferson's method. Then the third step of Hamilton's method is then round down. So we use the quota rule. We have to round. So we're going to round down. This rounds down to 10. This rounds to 5. This will round to 6. Everything rounds down. This rounds to 7. And this rounds to 5. So those are the first 3 steps of Hamilton's method. That's the first step of Jefferson's method. So we go ahead and we add these up. 10 and 5, that's 15. And 6 more, that's 21. And 7 more, that's 28. And 5 more, that's only 33 seats. Or in other words, we have 2 seats left over. So this is where Jefferson's method now changes from Hamilton's method. So step 2 for Jefferson's method is he says to put in a modified divisor. And a modified divisor, rather than use the standard divisor of 16,261.429, introduce a modified divisor. And what do we use? Well, it's kind of a guess and check type of thing. There is no set way of being able to do it. You just kind of guess. Now, since this is 33, that's too small, I'm going to lower the standard divisor to a smaller number. That way, when I divide it into here, I'll get a greater output, which of course we need more seats. So again, it's just kind of a guess and check. So how about if we try 16,000? This is our modified divisor. That's this right here, step 2 for Jefferson's method. So now if I use the modified divisor into each one of here, we'll come up with our modified quota, and that's what step 3 is. We come up using the modified divisor, gives us modified quotas. So we'll do that. So we use the modified divisor here of 16,163,200 divided by the modified divisor of 16,000. And this will give us a modified quota of 10.2. We do the same thing here. Use a modified divisor. 81,370 divided by the modified divisor of 16,000 gives us 5.086. We do the same for the next subgroup, the third ward here. We use our modified divisor, divide by the modified divisor, and this comes out to be 6.845. For the next subgroup, the fourth ward here, use the modified divisor of 16,000, and this is 7.366. And for the last subgroup here, the fifth ward, we use our modified divisor, 97,200 divided by 16,000, and that's 6.075. Again, we round down. This rounds down to 10. This will round to 5, rounds down to 6, rounds down to 7, and rounds down to 6. 10 plus 5 is 15, and 6, that's 21, and 7 more, that's 28, and 6 more, that's 34. So a modified divisor of 16,000 gives us these modified quotas, which round down, they add up to 34. So we're still one left over. So step 4 of Jefferson's method is to repeat 2 and 3 until there's no seats left over. So we'll do it again. So we did 16,000. We want to go even smaller because when we divide a smaller divisor into here, we're going to get a larger result out. So what should we do? Well, you don't want to go too big. So we'll go down to, say, 15,500. And again, it's nothing but guess and check. There's no specific way. You just kind of have to guess and check. So we'll try 15,500, and we'll go through steps 2 and 3 again. We have our modified divisor. Now we'll come up with our quotas. So we have our new modified divisor of 15,500. So 163,200 divided by 15,500. That gives us 10.529. 81,370 divided by our modified divisor of 15,500. That gives us 5.25. The next one gives us 7.066. This comes out to be 7.604. And our final subgroup here, 97,200 divided by 15,500. That's 6.271. Round down to 10. Round down to 5. Round down to 7. Round down to 7. And finally round down to 6. 10 and 5 is 15, and 7, that's 22, and 7 more, that's 29, and 6 more, and there we have it. There's our 35 seats. So the idea is to keep adjusting the standard divisor, called a modified divisor, that winds up giving adjusted quotas, wind up being modified quotas, and we keep adjusting it until we get the outcome that we need. The only drawback of Jefferson's method is it can get very tedious. But other than that, there we go.